Today's lesson is going to involve a lot of what we've learned the entire year. We're going to have to learn or remember how to solve equations. And more than just solve equations, we've got to be able to manipulate them, change the way the equation looks while keeping it balanced. Since we're doing linear functions, okay, we've got, we're going to be dealing with slope, we're going to be dealing with an independent variable, a dependent variable, we're going to be dealing with the y-intercept and the x-intercept, mostly the y-intercept, but the whole reason we spent all of Monday learning about the intercepts, you know, the x-intercept and the y-intercept, and the whole reason you practiced it yesterday was because in order to graph a line from its equation, or in order to get an equation from looking at the line on the graph, we've got to understand what the intercepts are and what the slope is, okay? And that's where all of this comes together, okay? We're actually going to come up with the equation, the y equals equation that describes any specific line. Okay, so here at the top of this, I believe this is the, let's see, this is the third or fourth page of your notes. Okay, that notes packet called Investigating Intercepts. Okay, you will also probably want a calculator, so go ahead and get the calculator, get everything you need for this, for taking notes today, and we'll get started in about 30 seconds. Remember, it's probably best to take notes in pencil. That way you can erase if you need to. Okay. Remember that these videos that I've made are also available on YouTube, that you can go and watch them anytime at home. If you need to review, you can watch them, rewind them, stop them, pause them, wherever you need to. That way you can watch at your own speed and things like that. Okay, you guys ready? Okay. Today we're going to talk about something that is specifically called the slope-intercept form of the equation. When we talk about the equation of a line, we're talking about this y equals, okay, this y equals thing, okay, this equation. It's got an equal sign, it's got a y and an x, and then normally it has a number in place of the m and a number in place of the b, okay? And we're going to talk about those things today. Alright, so if you look here, it says one form of the linear equation is called the slope-intercept form. Okay, the slope-intercept form. It's called that because the two numbers that are in the equation, okay, the two numbers are going to tell you what the slope is and what the y-intercept is. So we call it the slope-intercept form of the equation. Okay, any linear function can be written in this form, and it tells us those two things. It tells us slope and it tells us y-intercept. Okay? Okay, so when we read this equation, y equals mx plus b, or remember that y could also be written as f of x. We could say f of x equals mx plus b. When we read that, whatever number is in the m position, that's our slope. Now remember, we mostly see slope as a fraction. Okay, remember our slope is our change in y. Okay, that triangle means delta. That's the Greek letter delta. It means change in y over the change in x, okay? It's the slope. M represents the slope. And the letter B, don't ask me why it happens to represent this. I don't know. But whoever came up with it apparently was, everyone agreed with him. Okay? The letter B represents the y-intercept. Now remember what the y-intercept is. You practiced it yesterday. We learned about it on Monday. Okay? The y-intercept is the point where our linear function crosses over the y-axis. Okay, and it always has the value or the ordered pair 0 and then something for the y. Okay, 0 and then something for the y. So this next part says use the algebraic manipulation. Okay, that's where we add something to both sides or subtract something from both sides, or whatever it is we do, we keep the equation balanced. Okay, we're going to use algebraic manipulation to transform the following equation into slope-intercept form. And then we're going to determine the slope and the y-intercept from that equation. Okay. Now this probably sounds really confusing. This probably sounds really scary. You're just like, oh my gosh, Mr. Hahn, I can't believe you're not here and you're trying to teach us this. Don't worry. Okay. It's just like solving equations. You can do this in 2 steps. Okay. It takes 2 steps. We're going to solve for y. See this phrase right here? It says solve for y. If you think about it, up here, this y is all by itself, right? And it says y equals. Okay, so this y has been solved for. It equals mx plus b. Okay, so that's what our goal is. Our goal is to get the y all by itself. Okay, this guy right here needs to be alone. Okay, so if I'm going to get that y term all by itself, do you remember how we would get the variable by itself when we were solving equations? Let me show you an example over here. Do you remember when we had an equation that said 2x plus 4 equals 10? And I would say, okay, what do we do first? Okay, and we would always subtract this 4 first to get rid of the non-variable. Okay, well over here we're going to do the same thing. This is the thing that needs to be left alone, so we've got to subtract 6x. We've got to get rid of this 6x. Okay, we do that through subtraction because 6x was positive. So I'm going to keep it balanced by doing it over here also, minus 6x. Okay, now, like I always say, whenever we do something, we want to rewrite the equation. 6x minus 6x, that disappears. Now I'm left with a negative 3y. Some of you may be saying, Mr. Hung, where did the negative 3 come from? Well, remember this minus right here in front of the negative, in front of the 3? Since the 6x is gone, that doesn't disappear. It just travels right down here, and we treat it as a negative 3y. Okay, so we have negative 3y equals, and we're going to have 9 minus 6x. Why didn't I put the 9 and the 6x together? Why didn't I say 9 minus 6 is 3? Well, because 1 is an x term, and 1 is what we call our constant term. It doesn't have a variable. Okay, so that step was move the x term. Okay, that step was to move the x term. Okay, that's what we did there in step 1. Now, the good news is our y term is by itself, right? We have negative 3y. There's nothing else over here. But up here, do you remember, this doesn't say negative 3y, it doesn't say 2y, it doesn't say anything like that. It just says 1y equals. Y equals. So we need to get this negative 3y, this guy right here, to say 1y. Well, how are we going to do that? Well, in my opinion, I think we should probably divide by negative 3. Because if we divide by negative 3, this becomes a positive 1y. Okay? Now, if we divide that by negative 3, what else has to be divided by 3? That's right, everything. Okay? We have to divide 9 divided by negative 3. We also have to divide that negative 6 by negative 3. Okay, so 9 divided by negative 3. Well, positive divided by negative is a negative. 9 divided by 3 is 3. This negative 6 divided by negative 3, a negative divided by negative makes a positive. Okay, and that makes 2x, right? Because 6 divided by 3 is 2. All right, so the second step that we just did, this guy right here, was to divide by the number, and I'm going to use the number sign, the number in front of y. And we can do without that. We can do without the little quotation marks. Okay. Step 2 is divide by the number in front of y. The number in front of our y right here was a negative 3. So when I divided by negative 3 at every step, at every position of the equation, here, here, and here. Okay. Now, does this equation look like this equation? Well, it's got all the same parts, but it's not in the same order. So let's change the order of this, okay? Let's change it. Let's change the order of that equation so that it looks just like our formula up at the top, the y equals mx plus b. Okay, so let's rewrite it. Y equals, that was good, but mx, well, in my opinion, our mx is right here. That's 2x. So let's write that next. Let's do 2x. It was a positive 2x, so I leave it positive. And then my plus b, my y-intercept, my last number here is going to be this minus 3. Okay, so this is what that equation right here would look like in slope-intercept form. Those two equations are exactly the same. One is what we call standard form. Okay, this equation up here is called standard form. This equation down here is called slope-intercept form. Okay, and the reason it's called slope-intercept is because now we know our slope is right here. It's in the M position. And our y-intercept is right here. It's in the B position. So if this question were to ask, like it did, it said determine the slope and the y-intercept. Okay, determine the slope and the y-intercept. So now we could identify, we could say our slope, our m, equals 2, and our b, our y-intercept, equals negative 3. Okay, now we know those two things, and that becomes important when we start graphing linear functions on the graph based on their equation, which we'll get to when I get back. Okay, so that's what we're doing today. We're learning about the slope-intercept form of the equation, which is this guy right here, y equals mx plus b. Okay. Pretty soon we're going to do something where I just say, what is the equation of a line? And you're going to say y equals mx plus b. I'll say, what is the equation of a line? You'll say, y equals mx plus b. And we're just going to do that a bunch of times until it sticks in your brain. Okay? When we talk about the equation of a line, we're talking about the form y equals mx plus b. And that tells us our slope, and it tells us our y-intercept, and it gives us all the important information about our linear function. Okay, so I want us to go down here to number 5, and let's see if we can do this again. Okay, I know this is kind of new and kind of confusing. Okay, kind of new, kind of confusing. But you know what? At one point in your life, adding 1 plus 1 was new and confusing, and you learned how to do that. So you can learn how to do this. Okay, in number 5 here, they say find the slope and the y-intercept for each function. Now, when I hear something like that, when I hear them ask me to find slope and y-intercept, I'm going to remind myself that slope is m and y-intercept is b. Okay, remember that from the top of the notes right here? Okay, from this part right here. M represents the slope, which is the change in y over the change in x. And b represents the y-intercept, okay, which is our 0, comma, y point on the graph. Okay, so if I remember that, if you can remember that slope is m and y-intercept is b, and then one other piece of information to remember is that you have the equation y equals mx plus b. Okay, so if you can remember those two pieces of information, then you can answer these questions very easily. Okay? Let's look at letter A here. What number or fraction or value, I should say, is in the m position? Hopefully you said negative 5 over 4. Okay? So our m, our slope, is this negative 5 over 4. Oh my goodness, I cannot write. Let's try this again. Okay, we'll try this one more time. Negative 5 over 4. Oh, that was much better. Okay, that's our slope, right? That's our m value. So if the negative 5 over 4 is the m value, what would you say is the b value? Okay, hopefully you said that our b value is a positive 7. Well, congratulations, you have just identified our slope and our y-intercept from this equation. Good news is that was already in y equals mx plus b form, wasn't it? Y equals mx plus b. Okay, that's what we're looking for, where m is the slope, b is the y-intercept. Some of you may be thinking, okay, Mr. Hahn, I get it. M is the slope, or b is the y-intercept. I get it. Well, not everyone catches on that quickly, so be patient and let me repeat myself a million times because I probably will. Okay, let's try it again. Look at this equation right here. Letter B, f of x. Remember, f of x is simply the same thing as y. F of x equals 12x minus 35. Okay, 12x minus 35. Okay, so if we compare this, oops, wrong button, sorry. If we compare this to our y equals mx plus b, what number is in the m position? Our m should be 12, right? Because that 12 is in front of the x. The 12 is in the m position. Okay, and that leaves what as our b value? Okay, most of you probably said 35. What is this funny little sign in front of the 35? Okay, normally we say y equals mx plus b. Well, if I'm going to be plus b, what kind of b is this to change that plus to a minus? Well, that b must have been a negative. Oops. Let's try that one more time. It looks like a positive, doesn't it? That b must have been a negative 35. Okay, so that minus sign just tells us that our b value is negative. Okay, so now you know your slope and your y-intercept, your m and your b. Look at letter C. Okay, good news. Letter C says y equals. That's cool. Okay, what about this? Is this in the correct order? No, my m is always next to my x, and isn't it? It should always be mx plus b. Okay, it should say mx plus b. Okay, so our m is maybe not in the right order, but it is still the number next to the x. Okay, so our m in this case isn't the first number we come to. It's not the 60, but it's still the number in front of the x. It's that negative 6. Why is it negative? Well, because of this negative, or this minus right here. This sign is attached to that number, so it's a negative 6. Which then forces our b, our y-intercept, to be the positive 60. That's right. Okay, our b, our y-intercept, is positive 60. Okay, now those three examples were actually really straightforward. They were really easy, okay, because the equations already were in y equals mx plus b form, or at least something very close to it. Okay, they already said y equals. You'll see the next two equations here. Okay, the next two equations do not say y equals, do they? Okay, the next two equations have the x and the y on the same side. So these are not y equals. So these two equations here do not say y equals mx plus b yet. We've got to make them say y equals mx plus b. Okay? So we've got to change the equation. This is what we did up there. This is what we did right up here in this section, where we changed this equation. See how it did not say y equals? It had a bunch of stuff and then the equal sign. And we changed it and we did some different work, blah, 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 and then we got y equals all by itself. Okay, that's what we're going to do to these two. Okay, so let's look at letter D first and remember our steps. I wrote down the two steps up there. Step 1, if we're solving for y, if we're getting y all by itself, okay, if we're getting y all by itself, step 1 is to move the x term. Get rid of the x term from the side that it's on. Okay, so how am I going to move a positive 3x? Well, how did we move the positive 6x that we had over there? We subtracted. Okay, so we subtract 3x from here to get rid of it, which means we have to balance it by doing it on the other side. Okay, just like we practiced solving equations over and over and over again. Okay, so once we do something, we always rewrite. Okay, we're going to rewrite the equation now. 3x is gone, so now I just have 2y equals 5 minus 3x. Okay? And then if you look at that second step, I wrote it in red up there, the second step says divide by the number in front of y. What number is in front of y right here? 2, right? So we're going to divide by 2, but not just right here to get 1y. We're also going to divide by 2 right here and right here. Now, when we first started linear equations, I told you guys we're going to try to stick to fractions, right? And I know that scares you guys. You think, oh no, I've got fractions. That's okay. Leave them as improper fractions. You don't have to worry about it. Okay? So 5 over 2 does not come out to a whole number. 5 divided by 2 does not come out to a whole number. So I'm just going to leave it as 5 over 2. And then 3 over 2 doesn't come out to a whole number. So I'm going to leave it 3 over 2. And then I've got my x. Now, remember that y equals mx plus b is normally the way we see it. So over here, if we rewrite this, this is going to say y equals, and we would have a negative 3 halves x plus a 5 over 2. This is what the equation looks like right here. Okay? So if that's what the equation looks like, and I just realized I didn't want to put a box around that. That's not my final answer. Okay? If this is what the equation looks like, can you identify the m value and the b value? Go ahead and try to write down what is your slope, your m, and what is your y-intercept, your b. Okay, I'm going to write it over here to the left where I didn't fill up all the space. What is your slope, your m? Remember, the m is the number in front of the x. In this case, it's a fraction, kind of like on letter A, and it's a negative 3 over 2, 3 halves. So if that's my slope, what does my y-intercept have to be? That's right, the 5 over 2. Is it okay to have a fraction for my y-intercept? Sure, why not? A fraction is a number too, right? It's still a value on the graph, 5 halves. That's still a number on the graph somewhere. Okay, it's halfway between 2 and 3. Okay, so I want you to try letter E. I'm going to give you about 60 seconds. I want you to try to do letter E just like we did letter D. Go. All right, let's see how we did. Okay, the first step here, remember our first step is to move the x term. Right here we have a minus x. How are we going to get rid of a minus x? Okay, we've got to add x. Okay, so I add x over here to keep things balanced. This now reads, this is gone, so this now reads 4y equals 16 plus x. Okay, first step done. Second step, we've got to divide by the number in front of y. So I divide by 4. And not just one of the terms, all the terms get divided by 4 to keep things balanced. Okay, so 4 divided by 4 goes away. I've got y equals 16 divided by 4 is a positive 4. And here I've got a 1x divided by 4. So this is going to be a 1/4. Ooh, that was a terrible 4. 1/4 x. Okay. This time I'm going to leave it like this. I'm not going to rearrange it just because it's an unnecessary step. We should be able to recognize by now that the slope is always the number in front of the x, and the b is the other one, the one that we call a constant. Okay, it's all by itself. So our slope in this problem, our m, would be the 1/4, and our b, our y-intercept, would be the 4. Okay. All right. Last two problems on this page, and I'll be done for the day, okay, are special cases. Now, special cases, we've talked about them kind of a couple times over the past week and a half, okay? We've mentioned them. Probably the most important day that we talked about the special cases was on Monday when we talked about the y-intercept and the x-intercept, okay? Now, I want you to think about something, okay? Let's think about this. If I've got my little graph here, and they say y equals -10, okay, y equals -10. Y equals -10 way down here, right? And a y equals becomes a horizontal line. We talked about that a little bit, very briefly, okay? So first things first, if I've got a horizontal line, okay, what is the slope? It's automatic, okay? A horizontal line automatically has a slope of 0, okay? Then the question becomes, what is its y-intercept? So the first thing we have to ask ourselves is, does this line cross the y-axis? Well, yes, it does, right? It crosses it right. Ooh, that was bad. Let's try that again, sorry. Crosses it right down there, right? Crosses it right here. Okay, now we didn't label our graph or anything like that, but we know based on the equation that it crossed at -10. So that was the y-intercept. Okay, so we know slope and y-intercept. Every single horizontal line that says y equals a number will have a slope of 0, we know that already, and a y-intercept of whatever that number happens to be. If this example had said y equals 2, our slope would be 0 and our y-intercept would be 2. Okay, it's almost automatic. These special cases are really easy. Okay, horizontal lines. Now, if we do this other special case, okay, what kind of special case do you think we're talking about here? Yeah, you're probably right. Vertical line, right? And this one's at +6. We'll just kind of estimate where that would be, somewhere around here. Okay, +6 is about there, and that's all along that vertical line. What do we remember? Okay, do you remember what the slope, the m value, the slope of a vertical line is? Hopefully you do, because it's a special case. It's undefined. And then the b value, the y-intercept here, the b value would be, anyone got a guess? Where does this line, where does my red line there cross the y-axis? Well, I hope someone in here probably said, it doesn't have one. Right, it doesn't have one. It never crosses the y-axis, right? Here's my y-axis. Does it ever cross it? Does this red line ever come in contact with the y-axis? Will it ever come in contact with the y-axis? Okay? So a vertical line has a lot of special properties about it. Its slope is undefined. It doesn't exist. And its y-intercept doesn't exist. It never touches the y-axis. Okay? So the horizontal line is pretty easy. Okay? Slope is 0. The y-intercept is whatever number is right there. The vertical line is one of those things you just have to memorize. You just have to memorize. And remember that the slope is undefined and the y-intercept doesn't exist because it never crosses that y-axis. Okay. Tomorrow you will get to practice what we did on this page. You've got about 6 different examples to look at. You've got these 2 special cases to look at. Okay, I'm going to go ahead and kind of take a look at what tomorrow's assignment looks like. I'm going to go ahead and look ahead with you guys real quick. Okay, it's the last 2 pages of this notes packet. Okay, so it's the back of this page. Okay, it starts up at the top here and it says practice problems. Okay, now look at these practice problems. Okay, A, B, C, and D. They're not just asking about the intercepts, even though that's what these notes are about. They also want you to find the slope. Okay, on B and D, the slope should be very, very easy, right? B is a vertical line, D is a horizontal line. Okay, on A and C, you're actually going to have to choose 2 points and count your slope. Vertical change over horizontal change. Change in Y over change in X. Okay, and then they've given you a space here to write your x-intercept and your y-intercept. Write them as ordered pairs, please. Okay, 0, comma, y, x, comma, 0. Okay, your x-intercept and your y-intercept. On this next page, okay, number 2 and number 3, they give you a table. Okay, this is from the notes on Monday. Okay, you have these notes. Look back in your notes and see how do we find the slope on a table, and how do we find our x-intercept and y-intercept, and how do we fill in missing pieces. Okay, so number 2 and number 3, use the notes from Monday. Okay, you'll just fill in these tables, identify your slope from the table, and figure out your x and your y-intercept. Number 4, 5, and 6, those equations are already in slope-intercept form. They already say y equals mx plus b, so just identify slope and y-intercept, your m and your b. Number 7, number 10, and number 12 are all ones you're going to have to change into y equals. Okay, you're going to have to change them into y equals, following the steps on the notes we took today. Okay, number 11 is almost y equals already. We just have to divide by 6. Now remember, 2 divided by 6 is not 3. You're going to have a fraction. Okay, make sure to pay attention to where your numerator and denominator are. Okay, and number 8 and number 9 are special cases. Okay, use the notes from today to answer those 2 questions. Okay, you guys have done a really good job, I hope, over these past couple weeks. Thank you guys for being patient and working as hard as you have. One more day tomorrow. You guys are going to practice these practice problems. Okay, if you want to get started on them today, that's fine. Okay, they won't be homework. You'll have all day in class tomorrow to do them, and then I will be back on Friday. I look forward to seeing you guys. Keep up the hard work, and make sure that you've gotten everything turned in from while I've been gone. All right, see you guys soon.